My dear students, in previous class we were discussing the Raves test. What is the Raves test? If x and b is sequence of real numbers, and if a is greater than 1, then modulus of xn plus 1 by xn less than or equals 1 minus a by n for all n greater than or equals k. Then for all greater than or equals k, where k is any natural number, then sequence of sigma xn is absolutely convergent. And if a less than 1 with the modulus of xn plus 1 by xn greater than or equals 1 minus a by n for all n greater than or equals k, where k fall in n, k is a natural number, then sigma xn is not absolutely convergent. So the first part is we already proved. Come to the second part. If a less than 1, then we have to show that modulus of xn plus 1 by xn greater than or equals 1 minus a by n. If it possible, if this holds, then sigma xn is not absolutely convergent. How? So the proof of second part is, come to the proof. Consider if this equation 1, if equation 1 or 2, equation 2 holds there, what happens? Modulus for all, or if a less than 1, then modulus of xn plus 1 by xn greater than or equals 1 minus a by n. Agree? Modulus of xn plus 1 by xn greater than or equals 1 minus a by n. That means on cross multiplication it is modulus of xr by taking LCM, modulus of xn plus 1 by xn greater than or equals, it is n minus a by n. Clear? That means n into modulus of xn plus 1 greater than or equals n minus a into modulus of xn. Agree? What is a? Here a less than or equals 1. The choice of a is this less than or equals 1. Therefore this can be rewritten as n into modulus of xn plus 1 greater than or equals n minus 1 into modulus of xn. Clear? So what's your conclusion? Clearly this means n into modulus of xn plus 1 being a decreasing sequence. It is not decreasing, it is n into xn plus 1 greater than or equals n minus 1 xn, so it is an increasing sequence. n into modulus of xn plus 1 greater than or equals n minus 1 mod xn, clearly n into xn plus 1 is an increasing sequence. Okay, that means there exists some c positive, there exists c greater than 0 such that n into modulus of xn plus 1 strictly greater than this c. n into modulus of xn plus 1 strictly greater than c. That means modulus of xn plus 1 strictly greater than n by c. Modulus of xn plus 1 strictly greater than c by n. Okay. Therefore, sigma modulus of xn plus 1 strictly greater than sigma c by n. But what is sigma 1 by n? We know that sigma 1 by n being a harmonic series, it should always diverges. So sigma 1 by n diverges. That means sigma c by n also diverges for all n greater than or equals a particular stage k. So by limit comparison test, sigma modulus of xn plus 1 diverges. That means sigma modulus of xn not absolutely convergent. So this is the proof of second part of Raves test. So the test is important. If xn be a sequence of reals, and if a greater than or equals a greater than 1, and if modulus of xn plus 1 by xn less than or equals 1 minus a by n, then sigma xn is absolutely convergent. If a less than 1 and modulus of xn plus 1 by xn greater than or equals 1 minus a by n, then sigma xn is not absolutely convergent. So this is a Reip's test. Clear? Okay. Now consider an alternating series. What is an alternating series? Alternating series means a series is of the form. Consider a sequence. Let x equals xn be a sequence of real numbers. Then it is said to be alternating if the terms minus 1 power n plus 1 xn minus 1 power n plus 1 xn, where n is any natural number, n is natural numbers. So consider x equals xn be a sequence of reals. Then the sequence minus 1 power n plus 1 xn is said to be an alternating sequence. Sequence x equals xn is said to be alternating if the terms minus 1 power n plus 1 xn are either all positive or all negative. Okay, minus 1 power, say for example, minus 1 power n plus 1 of n. So the sequence is, it is 1, minus 2, plus 3, minus 4, plus 5, minus etc. So this is an alternating series. Minus 1 power n plus 2 sigma minus 1 power n plus 1 n is an alternating series. When it is an alternating, it means if sigma xn, if the series xn is, if the sequence xn is alternating, then sigma xn is an alternating series. So what is an alternating sequence? A sequence x equals xn of real numbers is said to be alternating if the terms minus 1 power n plus 1 xn are all positive or all negative real numbers. Consider this one. What about sigma? Or before going to the summation, what about minus 1 power n plus 1 1 by n? Consider this sequence. So it is when n equals 1, it is 1 minus 1 by 2, sorry 1, the terms are 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5 etc. So this sequence is said to be an alternating sequence. Then a sequence xn is alternating. If a sequence x equals xn is an alternating sequence, then sigma minus 1 power n plus 1 xn is said to be an alternating series. Okay, if xn is an alternating sequence, then sigma xn is an alternating series. What is sigma xn here? It is sigma minus 1 power n plus 1 into 1 by n, that is 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5 etc. Okay, so this is an alternating sequence and alternating series. X equals xn be a sequence of real numbers is said to be an alternating sequence if all the terms minus 1 power n plus 1 xn is all are positive or all are negative real numbers. Agree? If xn is an alternating sequence, then sigma xn is said to be an alternating series. So the examples are this one. Okay. Now consider an alternating series test. The result is known as alternating series test. What is an alternating series test? Alternating series test. So the test says that, this result says that, let z equals zn be a decreasing sequence of strictly positive real numbers. Decreasing sequence of strictly positive real numbers with limit zn equals 0. Limit zn equals 0. Then the alternating series sigma minus 1 power n plus 1 zn is absolutely convergent or is convergent. So this is alternating series test. This is important. Let z equals zn be a decreasing sequence of positive reals, decreasing sequence of positive real numbers. That's the crucial point. With limit zn equals 0, then the alternating series sigma minus 1 power n plus 1 7 is converges. How to prove this one? So the proof is in this way. Come to the proof. What is Zn? Z equals Zn be a decreasing sequence of real numbers. Decreasing sequence of real numbers means, come on, Zn greater than or equals Zn plus 1 for all n falling in. Since Zn is a decreasing sequence of real numbers, then Zn greater than or equals Zn plus 1. And later, Sn be the sequence of partial sums of this Sn, or sequence of partial sums of Zn, or Zn Z2n, but or maybe, or Zn, or minus 1 power n plus 1 Zn, sigma minus 1 power n plus 1 Zn. Since Zn is a decreasing sequence of positive reals, then Zn greater than or equals Zn plus 1 for all n falling. Let Sn be a sequence of partial sums of the series sigma minus 1 power n plus 1 Zn. So what is Sn actually? Sn equals, come on, Z1 minus Z2 plus Z1 minus Z2 plus Z3 minus Z4 plus etc. plus Zn minus 1 minus Zn. Okay. What is Sn plus 1? Sn plus 1 equals Z1 minus Z2 plus Z3 minus Z4 plus etc. plus Zn minus 1 minus Zn plus Zn plus 1. Enough. Zn minus 1 minus Zn, or Zn minus 2 minus Zn plus Z. So what do you get? Clearly, or for more convenience, you can take this S2n instead of Sn. Suppose what is S2n? If you consider S2n, then S2n equals Z2n minus 1 minus Z2n. Okay, Z2n minus 1 minus Z2n. So what about S2n plus 1? S2n plus 1 is Z1 minus Z2 plus Z3 minus Z4 plus etc. plus Z2n. It is Z2n minus Z2n plus 1. Okay. Clearly, S2n, so from clear, what is S2n? S2n less than or equals S2n plus 1. Sure. Okay. Or Sn less than or equals Sn plus 1. Whatever may be. So, S2n less than or equals S2n plus 1. S2n less than or equals S2n plus 1 means, what do you get? S2n, sequence S2n is an increasing sequence. Sequence S2n is an increasing sequence. Clear? But again, what is S2n? S2n can be rearranged as it is Z1 minus of Z2 minus Z3. Clear? Okay. Minus of Z4 minus Z5 minus of etc. Minus of etc. What do you get? Minus of Z2n minus 1 minus Z2n plus minus Z2n plus 1. Clear? Or this one. Z1 minus of Z2 minus Z3 minus of etc. Clearly, S2n less than or equals Z2. Since what is sequence Zn? Zn is a sequence of decreasing sequence of positive reals. So S2n less than or equals Z1. That means sequence S2n is bounded above. Okay? Bounded. So listen, S2n is an increasing sequence which is bounded above, then by monotone convergence theorem. What is monotone convergence theorem? If a sequence is an increasing and bounded above, it should be converges. That means sequence S2n converges. Okay. Now let's sequence Secant s to n converges means let limit s to n equals. Secant s to n converges, so let limit s to n equals s. Limit s to n equals s means by the definition of limit for all epsilon positive there exists some k1 fallen n such that modulus of s to n minus s strictly less than epsilon by 2 for all n greater than or equals k. Clear? But it is given limit z n equals 0. Limit z n equals 0 means again by the definition for all epsilon positive there exists some k2 fallen n such that modulus of Zn minus 0 strictly less than epsilon by 2 for all n greater than or equals k2. Put a k equals maximum this k1 and k2. So these two results are held for this k. Means modulus of s to n minus s less than epsilon by 2 for all n greater than or equals k, and modulus of Zn minus 0 less than epsilon by 2 for all n greater than or equals k. Then what about modulus of s to n plus 1? Then you consider modulus of s to n plus 1 minus s. What is modulus of s to n plus 1 minus s? What is s to n plus 1? S to n plus 1 is s to n plus z to n plus 1. Okay? S to n plus 1 is s to n plus z to n plus 1 minus s. Clear? What is s to n plus 1? z1 minus z2 plus z3 minus z4 plus etc plus that one. So it is s to n plus z to n plus 1. Okay. So that equals modulus of s to n minus s plus z to n plus 1. Clear? By triangle inequality, it is less than or equals modulus of s to n minus s plus modulus of z to n plus 1. What is modulus of s to n minus s? It is strictly less than epsilon by 2 plus modulus of Zn less than epsilon by 2. Therefore, Zn plus 1 is also less than epsilon by 2 equals epsilon. That means modulus of s to n plus 1 minus s strictly less than epsilon. That implies limit s to n plus 1 equals s. Limit s to n plus 1 equals s means the sequence s to n plus 1 converges to s. But what is Sn? Sn is a subsequence of, or s to n is a subsequence of s to n plus 1. S to n plus 1 be a subsequence of s to n plus 1 is a subsequence of s to n. S to n is a subsequence of Sn. Why? Because it is decreasing. Therefore, secant Sn converges to s. Secant Sn converges to s. That means secant Sn converges to s means secant Sn is convergent. Secant Sn convergent means what is Sn? Sn be the, what is the choice of Sn? Sn be the nth partial sum of the series sigma minus 1 power n plus 1 Zn. Sn be the nth partial sum of this series. Since Sn converges, then clearly the sigma minus 1 power n plus 1 Zn is also converges. That means sigma minus 1 power n plus 1 Zn converges. So this is the alternating series test. Test is important and the proof is also important. The test says that z equals Zn being decreasing sequence of positive reals with the limit Zn equals 0, then the alternating series sigma minus 1 power n plus 1 Zn is convergent. So this is the proof. Proof is important. Then after that, by using this result, now consider some problems. Test the convergence of sigma minus 1 power n plus 1 by n. We already proved that the harmonic series sigma 1 by n diverges. We know that sigma 1 by n diverges. What about the alternating series sigma minus 1 power n plus 1 by n? So for let Zn equals 1 by n. Okay, Zn equals 1 by n. So what about this 1 by n? 1 by n be a secant 1 by n. Therefore what is secant Zn? Secant Zn is a secant Zn means secant 1 by n. Secant 1 by n. Secant 1 by n is a decreasing sequence. Agreed? What is limit Zn? Limit Zn equals limit 1 by n. What is limit 1 by n? Is 0. Come to these two conditions. Zn is a decreasing sequence of positive reals. Agreed? Zn be a decreasing sequence of positive reals and limit Zn equals 0. Then by alternating series test, sigma minus 1 power n plus 1 Zn converges. Here what is Zn? That means sigma minus 1 power n plus 1 Zn means 1 by n that converges. So the alternating series sigma minus 1 power n plus 1 by n converges as well as sigma 1 by n diverges. Okay. Now we consider another one. Consider another series sigma minus 1 power n plus 1 by n square plus 1. Sigma minus 1 power n plus 1 by n square plus 1. What about the convergency? Here, let Zn equals 1 by n square plus 1. Okay. So what is Zn plus 1? Zn plus 1 is 1 by n plus 1 whole square plus 1. Clear? So what about Zn minus Zn plus 1? 1 by n square plus 1 minus 1 by n plus 1 whole square plus 1. Which is greater? This is a greater quantity, so it should be positive. That means Zn greater than Zn plus 1 for all n fallen n. Implies secant Zn is a decreasing sequence. What about the limit Zn? Limit Zn equals limit 1 by n square plus 1. That is always 0. So Zn is a decreasing sequence of positive reals, strictly positive reals. With the limit Zn equals 0, then by alternating series test, sigma minus 1 power n plus 1 Zn converges. That means sigma minus 1 power n plus 1. What is Zn? 1 by n square plus 1 converges. Clear? Okay, thank you.